Good day to everyone. I am Elvis Conrad F. Cruz, and I will be presenting my individual project on the comparison of using two different encryption techniques in ensuring the security of crypto. To start, I will be defining cryptocurrency. Cryptocurrency is a digital asset designed to serve as a means of exchange in which individual coin ownership records. It is special because it has a high exchange rate in the market. One example would be Bitcoin, whereas the exchange rate of Bitcoin equals 450,000 pesos and is slated to go up to 4.5 trillion pesos when 2030 hits. While cryptocurrency is groomed to be the next big thing, there lies a problem, and one of them is the crypto attack. Crypto attacks are hacks that steal money through attacking mining sites where cryptocurrency is stored. One example is the Nice Hash hack, where $64 million worth of Bitcoin were stolen from an attack. Hence, the question arises, what is the best security for cryptocurrency? Is it the current measure, which is cryptography or steganography? There are two main problems when it comes to the security of cryptocurrency. The first one is double spending, where it is defined as the act of spending cryptocurrency twice due to an exploit regarding the encryption. The second one is scalability, where there will come a time that when cryptocurrency booms, the number of transactions may take a longer time due to the complexity of the decryption and the lack of workers decrypting. Cryptography is defined as the study of secure communication techniques that allow only the sender and the intended recipient of a message to view its contents. Steganography is the habit or practice of hiding items such as a file, message, and image within a distinct file, message, and many more other channels. There are many more differences between the two security measures. One example is that the fact that cryptography alters the data structure while steganography's data structure stay as is. In order to determine which security measure is better, the researcher divided it into two criteria: reliability and viability. For cryptography's reliability, there lies one problem, which is the avalanche effect. The avalanche effect is a phenomena where when you change even one letter in the encrypted message, the whole sentence changes. As for steganography, it is shown to be reliable in having the message hidden. On one research, a steganography was not detected in a test that took 40 trials. One advantage of cryptography is the fact that it has a high success rate with a very low failure rate ranging from 0% to 5% when used correctly regardless of the message count. Whereas in steganography, it has a very high success rate only on pictures with a small word count. For the viability, one problem of cryptography is human error. Cryptography security is dependent on how well the user can protect its key from potential attackers, which may give rise to many crypto attacks if the user is not careful. As for steganography, it has shown to be viable, as simple populated apps like Facebook can be used as a steganography encoder. However, the same problem lingers, as this only holds true for small word count messages. But, in return, these two security measures could cost companies, both financially and physically, in factors such as CPU consumption, memory usage, and time consumption. We move next to the original content. For the original content, the researcher made an original receipt of a Bitcoin transaction, the leading cryptocurrency in the world. For the cryptography style receipt, the researcher used the shift cipher, where he used the key 3 to the right, which means that all the letters were moved 3 places to the right. Example would be the fact that the letter A would turn to letter D if the researcher used the shift cipher with a key of 3 to the right. For the text steganography, the researcher used random words to disguise the original message. If we look into the first message, Date Acquired Treasure East, we can see that the first letters of each word read the word date, which is the first message in the original receipt. As for the image steganography, a photo of Poe from Kung Fu Panda was used to hide the Bitcoin transaction. The researcher used Shao steganography, an app that creates simplified steganography. The process is as follows. First, the encryptor loads up the picture that he wants to hide the message from. Then, he loads up a note that includes the original transaction. Then he creates a password, which in this case is called math is fun. Then he will give the steganography to the decryptor. If the decryptor wants to open the file, he will press extract files and load the picture the encryptor gave. Then he will input the password, which at this instance, math is fun. Then he will press extract files. He will then save the file, and then there he can look at the message that was encrypted in the steganography. The researcher concludes that both can be viable security measures. For steganography, it is recommended to be the prime security measure if the person is more focused on cryptocurrency transactions that are low in value due to the better scalability that steganography gives. However, for cryptography, it is recommended to be the prime security measure if the person is more focused on higher value cryptocurrency transactions due to the higher success rate of hiding a message using cryptography and to the complexity of decrypting cryptography.